talking about this in some more detail, but we're not going to think about balance right now, but just think about sound. So what happens is your ears, here, they gather the vibration of someone's voice, my voice, your voice, whatever, and goes into your ear and hits the tympanic membrane and causes the tympanic membrane to vibrate. That's what the sound waves do. And the vibration of the tympanic membrane is amplified through the middle ear by the three little bones. And there's another picture which shows them in a larger profile. So the three little bones in here, the auditory ossicles in the middle ear, just amplify the vibration. And then the last of the little bones right here, the stapes, and again you'll see this in the bigger diagram, sits on a little structure called the oval window. So you've got vibration being transmitted across the tympanic membrane and being amplified by these tiny little bones. And one of them sits on a little thing called the oval window. Now, what you don't know, or you probably do because you've been looking at this perhaps, is the chambers in here are actually filled with fluid in a very kind of complex form. And the vibration here on the oval window sets up waves, literally, in the fluids inside the ear. And ultimately, those pressure waves cause little cells in the cochlea to vibrate. And when they vibrate, they send off neurotransmitters through one of the cranial nerves that you should remember, the vestibulocochlear nerve, number 8, to your brain. And your brain interprets that vibration as language, whatever language, English, Spanish, whatever it might be. So that's all it is. It's just a vibration. And that's amazing, isn't it? I mean, when you think about it, you pick up that vibration and it hopefully makes sense to you. Anyway, so it comes in through here, right? Sets up pressure waves in here. It's sound. And so that's what we're really going to have to explain tonight. The rest of this stuff in here with the semicircular canals, the vestibular complex, it's a very interesting anatomical structure in there, but way more information, I think, in the book than we need. But the idea is this: when you tilt your head from side to side or back or forward, you know where your head's going because there's little structures inside the vestibular complex that send that information to your brain. And that's why alcohol kind of interferes with equilibrium. So I know one of the usual tests you see on television is they'll typically tell somebody to tilt their head back, close their eyes, and take their finger and touch it to their nose. Well, if you've had a little bit too much to drink, your equilibrium's upset or something like that, you're liable to be here. Well, that's probably pretty much a trip to the back of the the police car and calling somebody up in the middle of the night going. So anyway, so that's what goes on in here. So the auditory ossicles, the malleus, the incus, and the stapes, they're the smallest bones in the human body, and there it is. You might pick this up, you might not pick it up, I don't know, but I'm going to show you. We've got this little plexiglass, looks like something you'd put a hot drink on. Gosh, it's been dropped, that's for sure. Not by me this time. But anyway, if you look at these guys here, these are the actual bones embedded in plastic because they're so tiny that they would just blow away at the if you walked by. So you can see how small they are in here. If you want to take a look at them, they're pretty cool. And these are the auditory ossicles. This is the malleus, the incus, and the stapes. The stapes looks like a little stirrup, and that's sometimes the common name they have for it. So here's what they look like. They're really tiny, but they vibrate and amplify the sound. Sometimes when people get older and they become hard of hearing, it can be the result of these bones becoming more ossified, and then they lose their sort of elasticity to vibrate, and that can be one source of deafness. But anyway, so the malleus is the first one, and that attaches to the other side of the tympanic membrane, and the malleus attaches itself to the incus, and the incus to the stapes, and the stapes onto the oval window, and they transmit the vibration into the inner ear. And what I talked about, the pressure waves and that sort of stuff, we'll get to in a minute here. But basically, that's what happens. So without the auditory ossicles, you would have a difficult time, hearing. Now, of course, sometimes, and we've talked about this, sometimes people think they're losing their hearing, and really their ears are just dirty. one of your jobs when you're in nursing school or something like that will be to clean out somebody's ears and restore their hearing. You'll be a miracle worker that day. They'll thank you profusely. Here's the picture of how the little bones are organized. So here's the tympanic membrane. This one here, this is the malleus. Here's the incus, and here's the stapes right here. And the oval window, the stapes has sort of an oval base. The stirrup has sort of an oval base, and it attaches on this thing called the oval window. There's one other structure on here that I often forget to mention, and I get asked about it, so let me do it now because I saw it on here. This little structure called the round window. The round window and the oval window function in hearing because you've got a pressure wave set up inside this chamber which results from vibration on the oval window. The round window is, in essence, to put it simply, sort of the release valve or the overflow valve or whatever for the vibrations, because suddenly it's quiet. You know, the vibrations disappear. Where do they disappear out of, or how does that happen? It's because of the round window sort of allows, you know, the vibrations to sort of, you know, level out. Another structure on here, you can see the auditory tube. And actually, let me go, oh no, okay. Let me go back here. This is one I want. I forgot to mention it. This is an important one. So here's the external, here's the middle ear. You can see there's a tube coming from the sort of back of the top of your throat, kind of. It's called the nasopharynx, but the tube is called the auditory tube. The old name that you probably would recognize is the eustachian tube, but we use auditory tube now. And the auditory tube goes into the middle ear, and it allows us to equalize pressure. You know, when you fly or dive or something like that, you had to equalize pressure in your ears. The auditory tube allows you to do that. And if you have small children, some of you as parents of small children, you may have had kids who suffer early in their years from chronic ear infections, middle ear infections. And the reason for that is in small children, this tube is quite short, and it ends in the nasopharynx, which is sort of kind of in the back of the top of our throat, sort of the back of our nose, in a rough sense. And any bacteria, things that are in the nose or throat area, can actually travel into the middle ear and set up a sometimes painful infection in the middle ear. The kids get cranky because their ears hurt and stuff like that. The good news for you all, if that's a problem for your kids, is as they get older and grow, the length of the auditory tube becomes obviously much longer, and the incidence of middle ear infections dramatically goes down. My kid, when Jeff was, I don't know, 2, 3, I don't know how old he was at the time, he had kind of that problem. But